these are selected answers for section 1.1 lines and planes. Like I told you in class, this is point L. For number 2, this is a plane L and M. And there's different ways you can name this plane. I'm going to leave it up to you. Number 3, we have line CD. And once again, there's a different way to name this line CD. Number 4, this is line segment PO. And there is another way that you can name this line segment. Number 5, this is a line, and you can name it EF, but there is other ways that you can name this line. Number 6, this is a ray, and then of course we have the endpoint, which is ST. So that's the ray. So those are some selected answers. You might have something different. I will definitely check your answer, but I just wanted you to have something so you can work from. Okay, remember what we talked about? Any 3 non-collinear points form a plane. So here's our plane. So we have points D, F, and E, and this is non-collinear, and this is a plane. Remember that 2 planes, in this case, remember plane is a flat surface that goes on forever. This plane, and then also this plane, do intersect at QR. Okay, so what it's saying here is that we have, in the figure at the right, points D, E, and F are non-collinear. These points lie in one plane. 3 non-collinear points lie in only one plane. 3 points that are collinear can be contained by more than one plane. You see that P, Q, and R are collinear and lie in both plane O and plane N. So the exercise that I gave you, you needed to identify the different points at what plane they belong to. Remember that we have F, G, and X, so it's F, G, and X, which is on this back side. So we're going to say this is in the back. We do have points F, G, and H. So points F, G, and H is that top plane. So I'm going to write top. We have H, I, and Z. So where is H? So we have H, I. Let me erase this. So we have H, I, and Z. So this is the plane right here in the front. Okay, so we have F, W, and X. So let me erase that. So we have F, W, and X. So you notice that it's the plane that's on the back. So that's on the back. I, W, and Z. So we have I, W, and Z, which is on the side, which is on the left side. The left side. Okay, so the next one that we want to do is the one dealing with Z, X, and Y. So we have Z, X, and Y, which is over here. I'm going to go ahead and color it. So Z, X, and Y. So here it is. It's in the bottom. It's on the bottom. Okay. H, G, and X. We have H, G, and X. So we have H, G, and X, H, G, and X. So that's going to be on the right side. And then we have W, Y, and Z. So we have W, Y, which is on the bottom. For the bottom, it says use a figure at the right to determine how many planes contain the given points. Note that line GF pierces plane at R, and line GF is not coplanar with X, and line GF does not intersect CE. So we're talking about C, D, and E. Actually, they're collinear, so it would intersect many planes just because they're collinear. So you got to remember that. So if I had, let's say I have 3 points that are collinear, and I draw this plane. I want to tell you that you can draw many planes, not just one plane. And I can show that here. So here's the blue, that's one plane. The red is the other plane. And you can have infinite amount of planes. Okay. 16, D, E, F, and you notice they're non-collinear, so it'd be one plane. As long as they're non-collinear, it's 3 of them, so we have D, E, and F, then it contains one plane. 17, we have C, G, E, and F, and it's going to be 0 planes. And 18, we have C and F, and it's going to be infinite number of planes.